Hello, this is LS574 Online Information Retrieval, and today we're going to talk about the database structure. First, let's define what a database. Here we have a definition, a collection, a database. What is a database? A database is a collection of related records in machine-readable form. A database may be of various types. Let's correct this here. I'm sorry for that. Of various types. For example, bibliographic, numeric, directory, or even full text. It is a computer version of a file. Okay. So what is a database? In general, we can think about a database about a collection of records, of any type of records. Okay. Of course. And let's say, for example, the catalog. When we talk about the catalog, is a database of bibliographic records, but we must not forget that you don't have the information item as such in the catalog. You have a representation. Okay, so the database represents, in the case of the catalog, information objects that are in the library or that are in the web. Okay, so it is a digital representation of information objects. That's in the case of a catalog. Okay, so what types of database do we have? Well, the one that I was mentioning, a catalog, that's a bibliographic database. We have numeric database, we have full text database, we have directories with links, we have image, sound, and multimedia. A multimedia database combines all the media that can be displayed in the computer. So we have text, images, and of course sound. That would be a multimedia database. Okay, some examples of database. For example, we have library information science tracks, library and literature and information science, ERIC, JSTOR, the WorldCat. It's a database. Our online catalog at Clarion University is a database. Okay, and databases are very important because it is a way to organize information. So a database is another definition. It's also a tool. Now a digital tool to organize information. Okay, so we can think about that. And now let's see the structure of the database. It is very simple. Information database are organized by fields, records, and file. A field is a single piece of information. A record is a record is made out of fields, and a file is a collection of records. For example, this is a file, and in this file we have displayed here 4 records: field 1, field 2, field 3, field 4. Field 1 is labeled ID. Field 2 is labeled article title. Field 3 is labeled author's name, and field 4 is labeled journal name. Okay, so when we see in this table the columns, we are talking about fields. When we see the rows, we're talking about records. So for example, record 001, that's field 1 ID 001, online learning, and Brian online. Record number 2 002, librarianship, Berlona Library Journal, and so on. So columns are fields and rows are records, and the whole all the records together, they form a file. Okay, a file is a group of records, and here we have fields: ID, article title, author's name, and journal name. So it is a very simple structure, one that we can do using Excel. For example, we can create our own database using Excel. We can have columns, and that would be fields, and of course we will have rows, and each row will be a complete record. And the whole file, it will be a file. Okay, the whole database will be a file. Another way to think about a database is when we think about a telephone book. When we have a telephone book with names and telephone numbers and maybe an address, that's a database. Of course, in this case, it's not a digital database, and it's not called a database. It's called a telephone book, but it's the same. For example, what are the fields in the telephone book? Well, the fields are name. Second field would be telephone number, and third field will be address. That would be column A, B, and C. What is the record? The record is the complete information with the three fields. And what is the file? The file is the telephone book. Okay. So we have here the book is analogous to a file. It's similar to a file. It contains list of records, and each record have three fields. In this case, name, address, and telephone number. Okay, so that's one way to think about a database. It is a collection of it is an organized collection of items. Now there's something in database, and this is interesting information, called inverted files. And the thing here, and I'm going to read the characteristics and the definition, is database construction requires a little bit more work. We focus on construction of inverted files, and you will see why this is relevant. In order to retrieve the data in the database, we need to index the fields. So fields have to be indexed. Why? Because it's easier and we can retrieve them more rapidly. The purpose to construct inverted files is to make searching easier. The computer does not need to go through the entire text of a document. Therefore, knowing how inverted files are constructed is useful to understand search and retrieval. And here we have another definition. The concept of inverted file type of index is as follows. Assume a set of documents. We have a set of documents. Each document is assigned a list of keywords. So to each document we assign a list of keywords with optional relevance weights associated with keywords. Okay, that would be an attribute. For example, document A may have a more weight because it's more relevant according to the keywords that we have assigned. An inverted file is then sorted or index of keywords, which with each keyword links to the document. So we have the document, we assign keywords, but the inverted file looks for the keywords and then retrieve the document. Okay, that's so it's not really complicated. This is the kind of index found in most commercial library systems. Okay, so we assign keywords to a document, and what the inverted file will do is search the keywords, and then it will retrieve the document. That's what it is called, inverted file. And this is what we use in library systems. The use of an inverted file improves search efficiency by several orders of magnitude. Why? Because it's not searching the document, it's searching the inverted file, in this case the keywords. Okay, and then it's retrieving the documents. So when we do search, we don't search the document, we search the keywords. Okay, and then the machine, that of course that's transparent to us, and then the machine retrieve the documents. Okay, this use of inverted files improves search efficiency by several orders of magnitude, a necessity for very large text files. The penalty pay of this efficiency is the need to store a data structure that ranges from 10% to 100% of the size of the text itself, and need to be updated, and need to update that index as the data set changes. Okay, so we are in a data structure, we are saving from 10 to 100% of the size of the text itself. However, it's more efficient again because what we are searching is keywords, and the keywords are assigned to the document, and the document then is retrieved according to the weights associated to that document, what we call relevance. Okay, that's the whole thing about inverted files. That's the whole idea about inverted files. Here we have another explanation. If it wasn't clear before, each document is indexed. Each word in a document is taken as index term with exception of stop words. Position in text is noted. 2. Indexes for all documents are merged. So we have an index of keywords. Index terms are arranged alphabetically in the bowl of the system. Under each index terms are document numbers in which it appears and position in text for that document. So we take the documents and we select some keywords in that document, and when we search the keywords, and then the keywords call the documents, okay, according to relevance. Here we have an example of an inverted file. Okay. For example, we have text: slow brown truck arrived, shipment of brownies damaged in a fire, delivery of brownies arrived in a slow truck, shipment of brownies arrived in a truck. And here we have the inverted file, the inverted index file, and we have the terms here. So arrive appears in one in location 4, in 3 in location 4. Let me see, 1 2 3, okay, 1 2 3 4, here it is, and in 4 location 4, 1 2 3 and 4. Brown, and so on. Brown appears in 1 2. So this is what we have indexed here, the inverted file. So when we search, we are searching here the index terms, the keywords, and the keywords will retrieve the file. And here are 2 examples. Okay, here's another example of how inverted files work. If you search digital and libraries, computer takes all documents under digital and all documents under libraries and compares to see which documents have both terms. That, of course, and we'll see that later, is using the Boolean operators, and, or, and not. Okay. Here another example too, that using the AND operator and how terms are being connected. So you can review this in your own. I just wanted to point out because sometimes it's a little bit confused how what is inverted file, but I think it's a simple idea. Okay, what it is indexed is the keywords. So each database type has its own structure to describe various parts of content for computer to recognize. You can recognize that a section of a document is a title, but of course the computer has to be told that a title is a title, and you do that by marking up language, for example. So the database knows, okay, I marked this as a title, and that goes to the title field. This is the author, that goes to the author field. This is the text, this goes to the author text. These are the citations, it goes to the citation index, and so on. Okay. Again, and this is very important when we do search, depending on the database, we can do field search. Okay. Many structure schemes were developed based on meta language that prescribe what to label and what to call the label by providers, vendor, organizations, authority in different subjects domains for different types of information objects such as text, image, audio, video. Mega tags are used on the web to describe and index. Semantic web is developed to further enable description and searching of meaning. To use this scheme for effective searching, you have no choice but to get familiar to these meta tags. And how do we get familiar to that? Well, there is, for example, there is something called the blue sheets in Dialog. Okay, and it's a description of the database. I'm going to show you the tags, and I'm going to show you the record structure now. In some database, description of a structure is readily available, and if I don't think it's complicated at all, but it may look complicated. A good example is blue sheets in Dialog. In other, and this is very important, and this is something that we have to practice to do online searching. We have to get familiar with the database to see what is the structure of the database, what are the fields that are indexed, and what are the fields that we can search. Okay, and that means that we're going to be a more professional searchers because we understand the structure of the database. So not everything sometimes is not spelled out. It may have or may not have a help feature. It will tell you what fields to search, etc., etc. So there are descriptions of databases. Of course, this is almost always true in commercial databases, in academic databases. So here one tip is, again, revelation comes from checking what is available in advanced search, search features, search tips, help, and the like. I, for example, like to use advanced search. For me, that's very it's easier to search, and I get more relevant results. Of course, most users do not take advantage of advanced search, so they don't use available structures in searching, and by available structures we mean what fields are indexed. But we, as professionals, as librarians, we should be able to use the advanced search to do our searching more proficient. Here there are two commercial open source or open to the public search engines, and they have advanced searching. Okay, but we rarely use the advanced searching when we use Google or Yahoo. Here we have one example of how records are structured. So please, if you have the time, go and click the link and go to the advanced, or search for advanced search in Google, for example, and try to get familiar with the structure. The same if you go to Google Scholar, you can search advanced search and see what the structure of the search is and what fields are available to search, and how you can combine terms or keywords, and how you can limit your search, how you can filter your search, etc. If we use all of those resources, our search will be, of course, more relevant. Here we have also the Yahoo Advanced Search, and we have the structure of the records. All vendors and search engines have a basic search by default and advanced search too. Almost all defaults and advanced capability different and have to be confirmed and study and get familiar to understand how to use them and to take advantage of those capabilities. All vendors and search engines have basic and advanced Boolean type search capabilities. I wouldn't say all, but almost all. How is it done and how is it differ? Well, it is very important that, and I have assigned homework 1. And in homework 1, we are going to compare a number of search engines and see how they work differently and how the results that we are going to retrieve are going to be differently too. All vendors and search engines rank output results. Of course, this is different. They have their own algorithms that we don't know what they are. but they use search engine use ranking by relevance, clustering, page rank. These are some of the criteria that they use and this is an algorithm. Again, it's a formula, it's a mathematical formula that they use to display the search engine results. What is the difference between the general public and us? There must be a difference. First, public users do not know or care about structure. Do not search beyond default capabilities, meaning basic search. Okay? Do not look beyond 1 or 2 pages of result. Miss many potential relevant results. Why? Because they don't go a little bit deeper. And they don't know what's under the hood, the structure of the record. Now, we as professional searchers, we know the structure is very connected to searching. When I teach my indexing class, I always tell the students that when we do indexing, we're doing the back end that will allow users to get to the information. However, users don't have to know how indexing is done, but we have to make sure that the index will point out to relevant information. We learned about use and we learned about and use available structures. And that's very important. We don't only use default capabilities. We use advanced search. Understand defaults and use advanced capabilities as necessary. Why? Because we want to search fields within the record structure. That's the whole idea. No tricks for not missing stuff and not getting too much junk. Explore in order to learn what is under the hood. So we have to become familiar with search engines and databases. Okay, that's the whole point. Searching is more an art than science, and that is why the only way to learn is when we practice. But we have to know a little bit about the structure, like we were talking today, about the structure of the database and what is a field, what is a record, and what is a file. Okay. Now I'm going to show you, just for your information, and you can click here to this URL about the blue sheets. The blue sheets. It's a web page, and I guess they were blue. They are still blue, but it's a web page now. They were in printed format in the past that specifies the structure of the databases that Dialog provides. Let me get that page here. Let me put it in here. Okay, let me make it a little bit smaller so we can use it here. Okay. And let me go back here. So you go to this URL and you go to Dialog, and you can read what the blue sheets are. It's a written guide for every database on the Dialog service. Again, any other database provider will have the characteristics of the database, and that's why we have to always look for the help file within the database. Okay, so we can search by database name, and let's go to the one that I had here. It's the our database here. It's let me see what it is. Okay, library and literature and information science. Its file number is 438. That's the file number of our disciplines database. We click here and we go here to the database. It has a file description. Here it is. Subject coverage, tips. Let's see what else. Print counterparts, if it has one. Dialog data file, of course. Here is the number. Document types index. It tells you what kind of documents are indexed in this database. books, monograph, conference, symposium, meetings, and of course journal articles. Let's see what I want to show you what is relevant here. Of course, contact, terms of conditions, but I want to show you the sample record. Okay, and this is the record. Remember, in week 1 and week 2 we were talking about the structure of a database and records. If we go to chapter 1 of the textbook, well, this is a record, and here we have the whole record. And remember, a group of these records is what we call a file, and each record is made out of fields. So what fields do we have here? We have the AA field, we have the TI field, that's the title, we have the AU field, that's the author, and then we have journal name, etc., etc. That's another field. We have an abstract field here. We have descriptors, and we have names fields here. So these fields that are there are indexed in this database. Okay, and here they are, basic index, and this is what they have index. Okay, and they have this additional index that we were looking at in the structure here. Let me go to the structure right here. So this is what it means. AA and the control number, author, AZ, dialog session number, BN, the international book number, company number, etc., etc., etc. These fields are also indexed. Okay, and remember when we were talking about that it is important to know the structure of the database, because when we go to the advanced search, and we're going to see that when we study each database, or not each, but when we study a number of databases, we'll see that when we go to the advanced search, we can search by field. Okay, we can take that, we can be more proficient searchers when we take advantage of the advanced search that allow us to search by field, for example, and we go beyond the basic search. Okay, so we have to, as professional searchers, as information managers, as librarians, we have to take advantage, we have to be more proficient searchers to help better our patrons. Thank you.